Wow, is that the rover? Yes, it is the rover. Check it out. Anyways, I work for the company that made many components for this particular assembly. This is the Mars rover. Goes to Mars. Pretty cool. I show you a blow up. Anyways, my workbench, always busy. Okay, I claim this CMM right here. This particular CMM is one of the most accurate ones in the entire world. As I have done some capability studies, I've zeroed a Deltronic pin. I've gone every 10 degrees. I get the nominal value for my actuals within plus or minus 40 millionths. Here's a part. This is a heart of a weldment. This compound of angles with a curved trough. This is a heart of an inlet weldment, and this thing goes in outer space for SpaceX. What you see here is a blow up of one of the wheels for the rover, and you can see the spokes that we made. We're going into room number 2. What we have here, it's a particular job, very, very tight tolerance. I want to kind of zoom in right here. There's a profile 0.0381. That is not inches, that's in metric. That's plus or minus 7.5 tenths on these slotted surfaces. There are some other critical features. The datum A is the flange. The datum C would be these two holes. And I go in these two little holes. If the part is off, maybe 30 thousandths of an inch, my program will still run. Anything more than that, I don't think it will. But let's watch how it works. Here's a job that we have to check 100%. Let's just go ahead, hit the button. Okay, it's just trying to find the part. Okay, we're rocking pretty good right now. It did take a hit on top of the part to establish a Z0. It measured one circle in this, what I call the timing hole. That's what we locate off of when we go ahead and put this on a 4th axis to do all the slots. Right now it's going underneath the flange and it's going to level. Well, first it will collect 4 points, 2 on this side. Change probe, come around the other side, collect 2 more points, create a plane. That is my datum A. It's leveled, and then a new Z0 is established. Now it's going to go into a datum C clocking hole. There's one on this side and there's one on the other. These are the main datum C clocking holes. After it measures this second hole, it'll have to go back up and measure the center diameter, which is the datum B. Of course, it zeroes that, X and Y, the center line of this diameter. As you can see, it avoids the star washer, kind of like the way we hold this part. Maybe 1/10 of clamping pressure. Just as long as it doesn't move, we are fine. You do not want to over clamp, as you will induce BS error. Now it's verifying the position of this particular timing hole that was used to create all the slots and the datum C holes. Actually, it just measured 2 chamfers, only 1 point. We did verify the angle during first article. This is a production CMM program in which we check all the parts 100% for the profile, which is so critical, of the plus of minus 7.5 tenths. Now this particular profile up here, we got a little bit more tolerance. It's going to blow that out while the tip is in that position. Then we'll start changing the positions and start checking these slots. One thing that I do try is whatever tip I use to level the part, I like to use that tip to check most of the profile points. Man, isn't that something? Goes right in there, comes right out. Like I said, the part can't be that, well, it can be off maybe 30 thousandths and my program still run. That's not too shabby. I also want to say that we are on a partnership program with this particular part. If I buy it, it goes right to the stock room. We have our process down. We do check the ID with a Deltronic pin. We do mic this OD. Those features are plus or minus 2.5 tenths. Once we know the ID OD are good, then it comes up here, and this is really the final inspection exercise. If it passes this program, I just tell shipping just wipe it down, get the fingerprints off, and ship it. I've been very fortunate not to get any of these back. In the beginning, there was some controversy who was right and who was wrong. Really like what we do here. We're very, very confident. We know we have the equipment to check these kind of tolerances. Another thing is, yes, this is the PC-DMIS software with the Brown and Sharp hexagon machine. This is a performance. The machine next door is the Advantage. And the Advantage, I believe, is one of the most accurate machines ever built. You can scan using the TP200. Once again, you don't need a scanning head. You can digitize using scanning software with this probe tip. It doesn't stick on the part and drag. It just takes like these single points. This particular program, it took me 6 full hours. There's a total of 172 measurements. It looks like it's almost done here. However, my customer requested I take a few more points because the very first run of parts that my customer had checked, first he bought them, the second lot he thought we had some high points right in this area. It's not a radical curve, so I didn't take as many points as he did. However, I didn't find any difference. The part was still good. The controversy lied. Evidently there was some dirt or some chip on his fixture, And when he mounted the part, he distorted it ever so slightly, but that's all it takes. Okay, this program is done. Took about 10 minutes here. This is a beautiful machine, TP200. Here is the our screen. It shows the model to the right. Obviously the model was used to create the inspection program. It was also used to make the part program. Anyways, this is what I do for a living. I just don't shoot pool. I check the most complicated, the tightest tolerance parts ever designed. I just figure if anybody can do it, I can. I got the equipment. I've been here over 5 years. I don't see anything come back. Once in a while you get some kind of, a bogus rejection, and then I have to squash it. And I'm really good at that. We are so confident at what we do here. We've been doing this for 30 plus years. Anyways, this is what I do for a living, and I hope you enjoyed this short video. I will be coming up with new pool videos pretty soon, as soon as I get out there. These CMMs, I believe, are the best ever built. Jet Propulsion Laboratories, they also use them. If it's good for them and NASA, it's good for GSP and myself. If you need some complex parts made, give us a jingle. We are GSP in Burbank. We'd be more than happy to help you out. It's always great meeting new people, new business, new challenges, and some new fun. Okie dokie. Thanks for watching.